Okay, so on page 118, we're going to continue finding the rest of the zeros because the directions on page 117 were for the polynomial 1 0 is given, find the others. Since all of these coefficients are real numbers, we know that this has to have a complex conjugate of 1 minus I. So I now have x minus 1 plus I as 1 0. And x minus 1 minus I as the other 0. And I'm just going to distribute both of these negatives, so I really have x minus 1 minus I and x minus 1 plus I. And I'm going to FOIL these two things together. So x times x is x squared, x times negative 1 is negative x times I is xi. Negative 1 times x is negative x. Negative 1 times negative 1 is a positive 1. Negative 1 times I is negative I. Negative I times x is negative xi. Negative I times negative 1 is a positive I. Negative I times a positive I is going to be a negative I squared. I just want to check something real quick. This x and this I should have been a positive xi. And I knew there was a mistake there because everything that has an I in it should cancel out. So xi, negative xi, negative I, positive I. And then this right here, a negative I squared, is going to be a negative 1, which makes it a plus 1. So I have x squared. And then I have minus 2 x's, and I have a plus 1 and a plus 1, which makes a plus 2. And I did all of that because now I'm going to take that and I'm going to do long division. So I'm going to have x squared minus 2x plus 2, and I'm going to long divide that into the polynomial here that I was given. X cubed plus 3x squared minus 8x plus 10. Double check that it's in order, nothing's missing, so here we go. To make x squared look like x cubed, you need to multiply by an x, and then x cubed minus 2x squared plus 2x. Subtract, the first ones go away. This becomes a 5x squared minus 10x plus 10. To make x squared look like 5x squared, you need to multiply by a plus 5. 5x squared minus 10x plus 10. And when you subtract, you get a remainder of 0, which you should have because this was made from two factors, thus making it itself a factor of the polynomial, which means when you divide this polynomial into the polynomial we were given, you have to get a remainder of 0. And then I found my other factor. So now I know that all of my zeros are x equals 1 plus or minus I, comma, negative 5. And I get the negative 5 from this one right here. Okay, the next one says give all the possible rational zeros for the polynomial. It's not asking you to find them, it's just asking you to list the possible ones. So I'm going to do p's over q's. So factors of 23 are plus and minus 23, plus and minus 1. And it's prime, so that's it. And then factors of q, the leading coefficient, are plus or minus 2 and plus and minus 1. So when I make my list of p's over q's, my possible rational zeros are plus and minus 23 over 2, comma, plus and minus 23 or 23 over 1, comma, plus and minus 2 over 1, or sorry, 1 over 2 is 1/2, and then plus or minus 1 over 1 is 1. So there's all my possible rational zeros. Number 8 says find all the zeros and factor this thing. So I need to find all the zeros and factor it. Okay, well, the only thing that these two things have in common is an x squared, so I'm going to try factor by grouping and see if it works. So I'm going to pull out an x squared, and I'm left with x plus 6, and then these two have a negative 1 in common, so I'm left with an x plus 6. So factor by grouping looks like it's going to work for me, which is really good. So I'm going to have x squared minus 1, x plus 6, and then this is the difference of two perfect squares, so this is going to be x plus 1, x minus 1, x plus 6. So f of x equals, so now I factored it, and my zeros are x equals negative 1, 1, and negative 6. And this is at a third degree, so you should have found 3 different zeros. The next one, factoring is not going to work so well because 11's prime, and there's nothing I can pull out to make the 11 match what's up here, so I'm going to quote-unquote smart kid cheat, and I'm going to throw this into a calculator. And so I'm just going to type this into the graph, 8x raised to the third plus 10x squared minus 11x plus 2. And this is the graph you get. And you can tell right here I go through negative 2. So I'm going to uncheat and I'm going to do negative 2 for my long division, and then 8, 10, negative 11, and 2. Pull down the 8, negative 16, negative 6, 12, 1, negative 2, remainder of 0. So now you have 8x squared minus 6x plus 1. And you can tell from looking at this graph, these other two zeros are not very pretty. So I'm going to do the quadratic formula. So x equals the opposite of b, plus or minus the square root of b squared, minus 4 times a times c, divided by 2 times a. So x equals 6 plus or minus the square root of, this is 32. So you have 36 minus 32, which is 4, all over 16. So x equals 6 plus or minus 2 over 16. So if I do 6 plus 2, 8 over 16 is 1/2, and 1/4, because 6 minus 2 is 4, 4 over 16 is 1/4. So I now can rewrite this in factored form. F of x equals x plus 2, x minus 1/2, x minus 1/4, and my zeros are negative 2, 1/2, and 1/4. Last problem on this page says find the zeros of the polynomial function and state the multiplicity of each. So this is already factored for you. So this is a 5th degree polynomial because 2 plus 3 is going to be 5. And you are adding these because it's in factored form. If it wasn't in factored form, you would just go, like up here, for example, the degree is 3 because 3 is the biggest power. This is multiplied out already. If you were to multiply this out, you would end up getting x to the 5th. So I know that x equals negative 8 is a 0, and its multiplicity, which is the power up here, is 2. And x equals 8 is a 0, and its multiplicity is 3. So now you can go back to Edmodo and watch the video for page 119.